Hello, good afternoon to all of you. Myself Amit Kumar Gangbar, Assistant Professor at Department of Electronics and Communication Engineering, Government Engineering College, Jalalabad. So this is lecture number 5. In this lecture, we will cover. We will in the previous lecture we have studied about the discrete Fourier transform. Then we study about the properties of the discrete Fourier transform. What are the properties of the discrete Fourier transform? We have studied all the properties one by one in the previous lecture. So in this is the unit number 3. We are currently studying. So today's topic is how to compute the DFT in the computer. So to compute DFT, now today we study the fast Fourier transform method of computing the DFT. What is how fast Fourier transform is computed? We will study in today's lecture. Fast Fourier transform. The fast Fourier transform is an algorithm that efficiently compute the discrete Fourier transform. The DFT is a sequence of action of length n is given by complex value sequence xk. Suppose there is a sequence xn for which we have to compute Fourier transform of the discrete Fourier transform of the xn. So as I told you in the previous lecture, by using the formula xk is equal to summation of n is equal to 0 to n minus 1 xn e to the power minus j 2 pi by n into k, and k will vary from k is equal to 0 to n minus 1. So this is the conventional formula which is used to compute the discrete Fourier transform. But this is very complex method. So in computer, how to compute the DFT, which is less computational complex and easily and fast and works and compute very fast discrete Fourier transform. So FFT is an algorithm which compute discrete Fourier transform in the computer. So in the xk is equal to, as I told, xk is equal to n is equal to 0 to n minus 1 like this. If similarly if we want to compute IDFT, it is xn summation of 1 by n and summation is equal to k equal to 0 to n minus 1, and similar, and this is formula we already studied in the previous slides. This compute the frequency domain information xk, and inverse discrete Fourier transform like this xn. We can compute the xn sequence. If we have this coefficient, discrete Fourier transform coefficient, we can compute the time domain signal xn. As I told you, Wn is a trivial factor whose value is 1 by nth root of e to the power j 2 pi. This is the trivial factor. It's also called a complex value phase factor, also called a trivial factor. It's nth root of unity expression, because when we take n common from here, then e to the power j 2 pi, e to the power j 2 pi becomes 1. From the above computation, as I told you, it is a very complex method to compute the DFT using the formula. So how to minimize the computation time, how to minimize the computational complexity of the DFT? So in the current using formula, how much computation required? In this, if xk, there is required n complex multiplication, because n is equal to 0 to n minus 1, it becomes n. So we need n complex multiplication and n minus 1 complex addition. N minus 1 complex addition, because addition of two number becomes, because we need to add only one time, so it's n minus 1 addition. Suppose we have to compute the n point DFT, and there is a n point sequence. If you want to compute n point sequence, DFT of n point sequence, so we need total n square complex multiplication, and n minus 1 complex addition. We multiply by n the original time required for the computation. Initially with 1 point sequence, then we need k n complex multiplication and n minus 1 complex addition. Suppose there are two n points, so we multiply n by original time required for 1 point sequence, we get the computational complexity required for the n point sequence, that is n square multiplication and n minus 1 complex addition. As I told you, there are two methods which are used uh, in the fast Fourier transform uh, for the computation of DFT. First is very popular. These are two very popular methods to compute DFT using FFT. So first is decimation in time algorithm and decimation in frequency. Decimation in time, as its name suggests, that decimation in time decimation in time domain based algorithm. So first we will study about DIT. Then in the next coming up lecture, we will study DIF algorithm. Discrete time, DIT, discrete in time, discrete in time, decimation in time algorithm. In this case, suppose now we will write the expression of the mathematical expression how this algorithm works. So in this slide, in the coming 2 to 3 slide, we will drive the mathematical expression how to compute FFT using DIT algorithm, how to compute DFT using DIT algorithm. So first, suppose let xn is a representation of sequence of n value, where n is an integer power of 2. N is an integer power of 2. Suppose n is equal to 2 to the power n. So suppose n should be if you want to compute the DFT of any sequence, the sequence length should have 2 to the power of n. Then only we can compute the DFT. Just like 2-point sequence, we can compute DFT. 4-point sequence, we can usually compute 8-point, 16-point, like this. 2 to the power 1, 2 to the power 2, 2 to the power 3, like this. Then only compute the DFT using this method, decimation in time. Using formula you can compute that DFT of any sequence, either it is 5 or 7 or 9 of odd number of sequence also. But if you want to compute using DIT algorithm, decimation time, there is precondition that the algorithm length should be 2 to the power L. Then we divide this sequence decimation broken into n by 2 points sequence, even and n by 2 point of odd. Now how it works, n point sequence is divided into 2 parts. This is the original formula of computing n minus 1 n point sequence, which is you see already. So if you want to now what we do, then these types of this algorithm, it divides the any sequence into odd and even parts. You can see this divide n by 2 points of even and n by 2 points of odd. It divides the sequence into 2 parts. Break the sequence into 2, even and odd. Suppose there is a 4-point sequence. So point is 0, 1, 2, 3. So 0 is even, 2 is even. So this is to 0, 2 points separate out, and 1 and 3 is odd, to separate out. So we will like this. This is the first step of this algorithm. We will break the sequence into n by 2 points. And this, like here we have break in 2 points. Substitute. Suppose how to get even number. So if we any number is multiplied by 2, any number and number multiplied by 2, just like 2 into r. If r will take any integer value, it will always give an even number. So r is 0, then it becomes 0, r is 1, then it becomes 2, and then r is 1, 3, r is 2, then it becomes 4. They always give even number. And for odd number, put n is equal to 2 and 2r plus 1. Suppose r is equal to 0, it becomes 1, r is equal to 2, r is equal to 1, then it becomes 3, r is equal to 2, then it becomes 5, like this. So we substitute n is equal to 2r and n is equal to 2r plus 1 in this expression, in this, which I break the sequence into even and odd part. You can see after putting x equal to 2r, in place of n it becomes 2r. Again here in the place of n it becomes 2r plus 1, becomes odd. And also r is equal to, now limit of the summation will also change, because when n is equal to 0, r becomes 0. N is equal to n by 2. Now you can see n is equal to initially n minus 1. When divided by 2, then become n by 2 minus 1. So after rearrange the terms, you can see we get 2 inside. We get 2 inside, and we take rk common outside the bracket. Similarly here we take rk outside this bracket. We want to simplify this expression, that's why we are doing these manipulations. Here w e power n w power 2 equal to you know w is equal to e power j minus j 2 pi by n. When we break whole bracket का square, then it becomes like this, e power j 2 pi n by divided by 2. So actually when this expression, then like it becomes wn. When n by 2, when we there here comes, you can see here n by 2, then here also it becomes wn by 2. Now the final, after simplifying this expression, you can see like this expression r equal to 0 to n minus 1 r equal to 2k, and this 2 comes in the denominator in the suffix of n by 2. Similarly here also this is 2, square of 2 comes to suffix of this. I think how it comes into suffix of 2 you can understand by this equation. Now we called as gk, we called this expression as gk, and we take wnk is common, and common from this expression, wnk common from this expression, because you can see e to power j 2 pi n into 1. From here you can take wnk common, we open this bracket, wn total factor bracket, then become wnk common here, then it is wnk. We write this gk and wnk is wnk, and this expression is hk. And k will value, k initial the k value become in previous slides you can see the k value 0 to n minus 1, but here when we break the sequence into n by 2 parts, then then now the value of k becomes k equal to 0 to n minus 2 minus 1. So this is simplify. We break the 8-point sequence into 4-point sequence, then we take the like this, arrange the terms, and we get like this. Now you can see this, I will show you this terms. Okay, this is the 8-point sequence. We break into 4-point sequence, x0 to x7. So we break the 4 point, these 1 2 3 4 are separate, and separate other 4 is separate. So if you want to compute x0, if you want to compute x0, what is x0? X0 is equal to g0, and one arrow is coming from h0. So it is nothing but x0 is equal to summation of g0 plus summation of h0. The point at node is it's nothing but summation of two values. So you can see we want to, if you put x equal to 0 here, then you can see x equal to 0 here, then you can see g0 and wn of k की power 0 डालेंगे, then it becomes 1 and hk. Similarly we put 1 2 3 4 like this. So this is x4. How to x1 x0 x2 x3 x4 x3 x4 x5 x6, how we compute x0 x4 x5 x6 x7, how we compute? We use the periodicity properties of the DFT, as I told you during the properties of DFT is periodic in nature. So now this gk and hk are n by 2 periodic, n by 2 point DFT, this is periodic in nature. Now this is periodic by n by 2. Now we break this sequence xk into 2 point, k is equal to 0 to n by 2 minus 1, and k is equal to greater than equal to n by 2 less than n minus 1. So it is, as I told you, it is periodic in nature. So gk equivalent to equal to gk plus n by 2. When we add n by 2, it becomes same. So it is periodic in nature. Similarly hk. The final expression we get when we put wn k n by 2, when we solve this expression, or when we simplify this expression, you will see wn k plus n by 2, you separate wn by 3, wn k into wn n by 2. Wn n by 2 become minus, that's why it becomes minus term here. After simplifying this expression, you get this thing. This is the final expression for both case. So if we put x equal to 0, then g0 plus wn की power 0, wn का 0 into h0. When k equal to 1, then we get g1 plus wn की power 1, n is 8 here, क्योंकि 8-point sequence hk. You can see here x1 is nothing but g1 into summation of h1 and multiply by wn of 1. You can see wn multiply. Here it is suffix multiply wn of 0 wf1. You can see from this expression there is suffix wn of multiply by wn of k into wn of minus k. It is the already in the formula. That's why from this expression we draw this graph. So similarly x4 is nothing but g0 into h0 multiply by wn4. You can see here if you want to x power 4 become means this will become along this expression, because for k equal to 4 to 7 here, k equal to 0 to 3 here, n equal to 8, then it become 4. So I have to come up on this expression. When we put g equal to k equal to 4, so then we k plus n by 2 plus wn power k h of k n by 2. As you told you, it is periodic in nature, so g0 is equal to g4. It becomes equivalent to 0 because it's periodic by n by 2, so it again gives g0 is equal to g4. That's why g in the place of g4 we again take g0, and h4 in the place of h4 we take h0. Similarly, like this we can get all the expression. Now again we have to further break this 8 point sequence into 4.4. Now we have 4 point sequence here, 4 point sequence here. Again we will break this 4 into 2 by 2 into 2, and this 4 is equal to 2 into 2. You can see n by 2 we will break up further, n by 2 here, n by 2 here. But in the previous case, how we break, we can see here n by 2, how we break n by 2, n by 2. Now we break n by 2, n by 2 sequence. Now these 4 sequence will be break by n by 4, n by 4. Here n by 4 means 2 sequence here, 2 sequence here, 2 here, 2 here. So because we break further into 2 into 2. So after so how we will get g0 nothing but coefficient of a0 into summation of b0. Similarly, it's symmetric, it's behave like a symmetric. How it we get this? Similar manner we will get this. Similarly, we break how will we get a0 nothing but x combination of x0 into x4. You can see in the next slide, a0 is a0, x0 and x4. So it's a symmetrical. If you understand how we get these x0 to x7, you can get from how we get x0 to x7 from g0 and h0, g and h. Similarly, how we get g and h from a b c d, and similarly how we get a b c d from x0 x4. You can get it's a small x, it's a capital X. Capital small is the time domain and capital in the frequency domain. So this is the final simplification expression you can get easily. This is nothing but you can easily break further into g. You can break g further into a and b, and further ab further break into x0 and x4. This is the symmetry expression. So it looks like very difficult. When we solve problem, it is very easy. Actually, it is very easy. You know, don't worry how we will learn this thing. It is very easy to learn. It is very easy to understand how it is happening. But it looks like very difficult, but it's very easy. Trust me, when you solve the problem, you feel that it is really very easy. So suppose this is the final expression. Now we put you can understand, draw the 8 lines like this, then draw this x0 line to x4 like this. You draw like this 4 lines, draw like this 4 lines, and write w8 is to 0, w8 is to 1, like w8 7. Similarly, write w8, w is 4 by 4, because then w4 0, w4 1, w4 2, w4 3, w4 0, then w4 0, w4 1, w4 3, w4 3. So again break into 2 by 2, then w2 0 and w2 1, w2 0, w2 1, w2 0, w2 1. You can easily compute value of the total factor from open this total factor w is equal to e power minus j 2 pi by n, and whatever value is given, that multiply by this w power 0. When 0 multiply, open the expression and multiply by 0 becomes 1, so it will become 1. How it becomes w8 power 0? Open this and open in cos and sine terms, you will get the value. Similarly, further simplify this expression, we will get like this. You have to remember only these things, nothing else, and you can easily solve this any problem of 8-point DFT using DIT algorithm. You have to actually w8 power 0 becomes 1. In the place of 1, we don't show anything. 1 if nothing there is in the expression, it means there is 1 present in this here. 1 is present here, 1 is present here. If there is minus 1, if there is minus 1, then it is present minus 1. You can just see the symmetry. The 4 is nothing, only 1. Next is minus 1. Here you can see 2 is 0, nothing. Again 2 is minus 1. This minus 1. 2 is nothing. Again 2 is minus 1. Here 1. Here minus 1. Here 1. Here minus 1. Here 1. Here minus 1. Like this, and you can easily solve any problem. One thing you have to see here, you get the sequence x0, x1, x2, x3. line in the sequence manner in the ascending order, but here you can see x0 and x4, it is not in the sequence. This is, you have to put here very carefully, put here x0 value in the and x4. Then suppose you want to compute value here, then it is nothing but x0 plus w4 x4 and x4 of w4 power 0, it is nothing but 1. So just you can get here, and if you want to compute here, this point, it is nothing but x0 plus x4 into multiply by -1 into x power -40, like this. When we compute here these values, then we'll move to here, compute these things, then we can compute this value only. We have to go from left to right. First we compute this value, then we compute this value, then we compute this value. This is the numerical. We will solve this question in the next lecture. Then you will see it is very simple. Now I will actually solve this in pen and paper. I will solve in my copy. Then I will show you how to get this expression, and further with the help of slides also we will try to explain you how we solve this expression. This is very simple. I will tell you the steps, and I will tell you how to compute the values of this expression w80. You can easily get the value from this expression. In the next slide we will solve this numerical. First we compute 8 point DFT, then we compute 4 point DFT, then it becomes, the concept will be becomes easy for you. It's very simple, trust me. Once you try to practice 1 or 2 numerical, this algorithm is very simple, and you will become very comfortable after that, once you practice 1 or 2 numerical 2 examples. For today, I think for today I am stopping here. Next lecture we will solve some numericals on DIT algorithm, then everything becomes clear to you. If you face any difficulty, kindly write a mail to me that you are facing this difficulty. We can conduct an online session for that, and we can solve your doubt. So don't hesitate to mail me, don't hesitate to discuss any concept with me, because until unless you don't ask me, how I will know that you don't understand the concept. So always, whenever you stuck, kindly ask me. I will solve your doubt. Thank you.